Okay, now the question arises that what will be the derivative of a to the power x? So by derivative, we all know what we are trying to say. Say I'm looking at a derivative at the point 0, then the slope of the tangent line, right? So we will certainly use first of all the first principles and try to look at it. So using first principles, what do you think it is? So what we have to actually find out is this: the limit of change in x being converging to 0, f of x plus change in x minus fx upon delta x, or change in x. Okay, so what we have here is, now our function is a to the power x. Our function is a to the power x. So this becomes a to the power x plus delta x minus a to the power x whole upon delta x. Okay, right? So this becomes limit change in x going to 0, change in x going to 0. What we can do is, can you see something peculiar here? Essentially what is there in the numerator is a product of a to the power x into a to the power delta x minus ax, right? So I can take it out as common. I can take out ax as common, and what remains inside is a to the power delta x minus 1 over delta x, right? Okay, so now essentially the derivative of a to the power x will be a to the power x getting multiplied to some limit. What is that some limit? That some limit is limit delta x tending to 0, a to the power delta x minus 1 upon delta x. That is what this limit will be. Now consider the point 0. If you look at point 0, f dash x or f dash 0 will essentially be this expression. Why? Because x has been taken as 0, right? So f dash x essentially is equal to a to the power x into f dash 0. If you take, see what will happen if you take f dash 0, that will be a to the power 0 into multiplied by this term. Okay, this term essentially is nothing else but f dash 0. This term is nothing else but f dash 0. Okay, get into the details of it now. Now, so f dash x will equal to a to the power x into f dash 0, or d by dx a to the power x at x equals to 0. This term is essentially this. Okay, now this term can be taken as some function of a, because it will be some function of a, into a to the power 0 into a to the power 0, because this is some function of a to the power delta x minus 1 upon delta x. This is some function of a, right? So I am quoting it as GA into a to the power 0, which is GA itself. So GA is essentially what? GA is the slope. GA is the slope of a to the power x. GA is the slope of a to the power x at x equals to 0. This is, this is a to the power x. So it's a slope of a to the power x at x equals to 0. Now, this implies from here we come to the definition of our common natural exponential function. The letter E is such a letter or such a number whose f dash 0 equals to 1, and hence we get the derivative of Ex is simply Ex, because the term attached here, which is GA, which is essentially the derivative at 0, is equal to 1. So that is why the derivative of Ex is itself. Okay, so we say that GE equals to 1. We say that GE equals to 1. So essentially we are trying to say is that E is such a number, such a unique number, such a unique positive number for which what is happening? The limit h tending to 0, EH minus 1 upon H equals to 1. H is nothing but your delta X. You can quote it as H or delta X, anything. So just to differentiate, I've taken it as H out here. So E is such a number that this thing comes out to be 0. Now if GE equals to 1, what will be d by dx Ex? As I said, it will be itself. What will happen? It will essentially be GE into e to the power x, where I have already said that this is a number where GE equals to 1. So GE equals to 1 into e to the power x, you get e to the power x. Okay.